the quadratic formula is given here. From that, we can determine different parts of that formula will tell us different things about the quadratic equation. So b squared minus 4ac is the expression underneath the radical. It's called the discriminant. So that word makes sense. We're going to, from that value, decide how many roots we have. We'll either have two distinct real roots. So that's if we graph the corresponding function, it touches twice. So there's two examples there. If we graph the corresponding function and it just touches once, really what's happening there is we have a function with a multiplicity of 2. So the equation, when we solve it, would have one solution. But sometimes we will talk about it as having two equal real roots, because then we know that it's a quadratic. And then two non-real roots means it does not touch the x-axis at all. So in this case, really, they would have complex or imaginary roots. Okay. But that's not what we're not going to learn about those. We're dealing in the real number system. So we're not going to learn about those. If you do take Math 31 HL, you'll learn a whole lot more about complex numbers. Okay, so I'm going to go through full solutions here to solve these quadratics using the quadratic formula. So we've already done some practicing. If you want to just go right in to entering your values, that's fine. But I do want to see what you substitute in, okay? Don't just follow all the way to the simplified. So show me what you're putting in there. That gets you part marks, because sometimes students will do the rest of the simplifying incorrectly. Then at least you get part marks if you show me this. So 36 minus 32 is 4. Notice how you can actually take the root of 4. So you're not going to get imaginary solutions, guys. And so here, now simplify. This is not not irrational anymore. Actually find the values. -6 plus 2 is -4. Divided by 2 is -2. -6 minus 2 is -8. Divided by 2 is -4. So there are two solutions. If you get integers or rationals, that means you could have factored it. If you get irrationals, then you don't have a choice. You either have to have use completing the square or quadratic formula. So here, square root of 0 is 0. So whether you add 0 or subtract 0, you get the same thing. You get one solution there. Or you might call it two equal solutions. Okay. Can't take the root of a negative. Okay, so there are no solutions. Sometimes we use that null set. Okay. All right, so the nature of the roots, this we describe as two distinct real roots. Distinct means they're different. So if you were to use the word different, that'd be fine as well. This one, we say one real root, okay? Or you could say two equal real roots. And that's common to see, okay? So we might put that as an option on a test. Maybe you won't see one real root. So two equal means the same as one real. And here, there are no real roots. Okay. Now, the value of the discriminant, remember the discriminant is b squared minus 4ac. That's the value underneath the radical once you simplify. Okay, so the value is 4 here. The value is 0. The value is negative 4. Notice how this is positive. This is 0, and this is negative. That's really what's important. Is the discriminant greater than 0? If so, you get two distinct real roots. If it's equal to 0, you get two equal real roots. And if it's negative, you get no real roots. So that's what you have to look at. So sometimes we might just ask you, describe the nature of the roots. We just want to know how many, what kind. You don't have to go through the whole quadratic formula. Just do your b squared minus 4ac. Okay. So that's going to save you some time. Then sometimes we'll be asking you to find the value of a coefficient in order to make that equation have a certain number of roots. So that's what's basically on the next page. I'll fill in the chart here. So greater than 0, two distinct real roots, two equal real roots, or one real root, and then no real roots. And you need that statement, the real number system, so no real roots, two distinct real roots. Okay, so this one, state the nature of the roots. First of all, you have to have it in the form ax squared plus bx plus c equals 0. Okay, so you can't do that right now. So turn over the page. This is on the next page. Expand that out and get it into that form. And again, I would want to see what you're substituting, and then you can come up, you can use your calculator for the rest. Okay, you get a negative. Okay, so the discriminant is less than 0, therefore no real roots. Okay, so that's kind of what I want to see. And then example 2, it says, determine all the values of k if the first one has 2 distinct real roots. So that's when you got to know what the discriminant needs to be. So 2 distinct real roots, the discriminant has to be greater than 0. Okay, so that means when we look at this question here, b squared minus 4ac has to be greater than 0. This is already simplified. So a is 2, b is negative 6, c is k, and we substitute that in. And you want to solve for k. Okay, so we want to get k by itself. Just need to be careful when you're solving an inequality. What you might want to do is bring this over to the right, okay, to make it positive, and then the k is at the small end, it's the lesser, right? If you leave it like this and bring the 36 over, it becomes negative, but we need to get this k by itself being positive. So we would divide by negative 8. All right, and then when you do that, when you divide an inequality by a negative, the direction of the inequality changes. Okay, so be careful on that. So this will end up being positive 9 over 2. Okay, really important that you remember that. Then you could always test the value. So what's a number that's less than 9 over 2? How about 1? Right? If we put in 1 here, then we would put in 1 here, right? So that would be 36 minus 8, which is a positive. That's what we wanted, okay? If we had got the sign mixed around, then it would be something, maybe you put in 10, right? The other way. And so then you would see you would get a negative value. So it's kind of like testing those inequalities that we were doing a while ago. Okay, and then the same with the next one. In this case, exactly 1x-intercept. So now notice how it's not 0 equals. It's y equals. Okay, so this is representing a graph of a quadratic. But remember, the x-intercept of a graph is going to be the root of the corresponding equation. So we still go through the same process. So here, for exactly 1 x-intercept, that means our discriminant has to be equal to 0. And in this case, it's y equals, it's in standard form because there's the x squared term, the x term, and the constant. Just so happens, though, that a is 2 terms. B is negative k, C is 1. Okay? So you're going to have an equation in terms of k that you need to solve. When you square a negative, it's a positive. And take a look. It actually ends up that this ends up being a quadratic. So now you have to solve this quadratic, even though you're doing a discriminant. You actually have to solve this. But it can be factored. So there's two possible k values. You can always check it by substituting those back in, right? So let's do a check here. If we say k is equal to -2, then we would have y equals -2 plus 3 is 1, so we get 1x squared. Subtract k, so subtracting a negative is adding, plus 1. Okay, and if you think about that, that's the same as x plus 1 squared. So that has an x-intercept of -1, multiplicity of 2. Makes sense. Then if we check k equals 6, we have y equals 6 plus 3 is 9x squared minus 6x plus 1. And again, that can factor to 3x minus 1 all squared. So an x-intercept of 1/3, multiplicity of 2. So you can check your answers. All right, and so we're done. So now we're kind of in May ahead. So tomorrow we're going to do what's scheduled for Monday. And then Monday we'll do what's scheduled for Tuesday. And then Tuesday will be a review day. All right. I'm also going to hand back your test today. Not for a little bit. I'm going to give you about 20 minutes to do some work. We have WISE time today, so we'll do it during WISE time. Okay, in about 20 minutes.